So for the instruction set, we have to refer the chapter 3. Quickly I will be referencing those instructions from the chapter 3. There if you see, there are 3 major classifications of instructions. First type of instructions we call it as data processing instructions. Data processing instructions, all arithmetic and logical instructions and compare instructions come are data processing instructions. So here you can see data processing instructions, right? Data processing instructions were again classified into arithmetic operations. Here you can see add R0, R1, R2. What do you understand from this add R0, R1, R2? What do you mean by add R0, R1, R2? Content of R1 is added with R2 and the result is stored in R0, something like this. R0 will have the sum of R1 and R2 values. So add with carry R0, R1, R2. So R0 will have the content of R1 plus R2, which is along with the carry flag. It is add with carry. Similarly, subtract R0, R1, R2. R0 will have the difference of R1 minus R2. And subtract with the carry means difference of R1 minus R2 is carry minus 1. And reverse subtraction. RSD means it is reverse subtraction, which is very clearly given. Reverse subtraction. What do you mean by reverse subtraction? R2 minus R1. Reverse subtraction is R2 minus R1 is reverse subtraction. And reverse subtraction with carry. Okay. R2 minus R1 plus carry minus 1. Okay. So addition 2 instructions, subtraction 2 instructions, reverse subtraction 2 instructions. So the few samples which describes the arithmetic operations of ARM instructions to begin with. Okay. Similarly, logical operations. We have AND operation, that means AND R0, R1, R2 means the content of R1 is ANDed with R2 and the AND result is available in R0. And result is available in R0. Okay. ANDing operation is used for masking the corresponding bits. If you want to mask a corresponding bit, definitely we can use AND operations. Similarly, OR operation is used for setting the corresponding bits. So, to set the corresponding bits in R0, R1 content, R2 content need to be ORed and the result will be in R0. So, R1 ORed with R2, the result is in R0. So, AND operation, XOR, OR operation. And XOR operation is used to find the similarity between the two bits, which is mostly used in communication where whether the transmitted bit is received properly or not, something like that. Okay. Okay. So R0 equal to R1 and not R2. R0 equal to R0 and not R2. Okay. So it is not and it is logical operations, right? Okay. So BIC means bit clear, where every one in the second operand clears the corresponding bit in the first operation. Okay. So bit, then register movement operations. So moving the, as usual, right? We can move the content between registers. So moving between the register means we can use move instructions as shown here. Move R0, R2 means R2 will be loaded with R0. Move negate means R2 is complemented and stored in R0. Here there is something like comparison operations, register movement operations, here comparison operations. Here it was misaligned, right? In the book it was misaligned. Actually it is compare R1, R2, compare negate R1, R2, test R1, R2, test equal R1, R2. That is given, right? Okay. So whenever you are finding it equal, means you are going for XOR operation, right? Whenever you are testing, right, whether it is present or not means so masking kind of things, we can go for AND operations. For testing, we use AND operations. For whether finding the equality or finding the similarity, we go for XOR operations. Okay. So compare means subtraction, as we all know. Compare negative means it is addition, right? Compare means subtraction. Compare negation means it is addition, right? So CMP R1, R2 means set conditional code. What do you mean by CC? Conditional code, right? Comparison. Conditional code on R1 minus R2. Compare the content of R1 and R2. That means R1 minus R2 will be subtracted and the flags will be reflected. ZCC means the flags will be reflected. Compare means compare, compare negated, test, TST means test, and test equal. So comparison operations. And again, we can add the two numbers by using hash symbol, right? As usual, right? Hash symbol. Hash means only 8-bit, right? We can do the immediate data transfer. Add R3, R3, hash 1. This hash 1 is misaligned, right? R3, R3, hash 1. That means R3 equal to R3 plus 1. That's all. And R8, R7, hash and FF means. So, and the content of R7, right? Then shifted register operands. There is something like shifted register operands. What do you mean shifted register operand means? Logical shift, arithmetic shift. There is something like logical shift and arithmetic shift. So left shift and right shift. In the one left shift and one right shift is possible with respect to 8051. But here we can go for multiple left shifts and multiple right shifts with respect to ARM processor. So arithmetic shift preserves the sign bit while shifting left as well as while shifting right. Logical shift means there is no arithmetic operations. It will never preserve the sign. How many shifts you have to do? Only one shift in 8051. But here you can go up to 32 shifts in all ARM Cortex basic series. That is very important. Okay. So for doing that, there is one hardware module called barrel shifter. So because of the presence of this barrel shifter, while the instruction is fetched from the register to the ALU, on the way from the register to the ALU. So this is register bank, right? R0 to R15. On the way from the register to the ALU, because of the presence of barrel shifter, whether one shift or two shifts or 10 shifts or 15 shifts or 20 shifts or 24 shifts or 32 shifts, can be just like that done on the go from the register to ALU. Hence it enhances performance, speed. You can see there is a separate bus from accumulator A and there is a separate bus from the accumulator B, and the ALU is giving the product. That is the sum or difference or whatever you call. That you go for ALU bus. That is going to the, again the result register is R0, means it will go to the result register, and the program counter is R15, right? Hence the program counter is R15. So program counter is notifying the address to the address register, which goes to the corresponding program memory and fetches the instruction, and the instruction fetching is done through this fetching decoding. After decoding and process will be like this. Okay. So because of the presence of the barrel shifter, there is a possibility for us to shift on the go. It is one of the special features with respect to ARM, which will enhance the speed of the thing. So this is the one on data flow with respect to ARM, right? Here so R3, R2, R1, LSL hash 3 means logical shift left to 3 locations, something like this. So 3 locations means shifting left means multiplication. So multiplication by 2. 1 shift is multiplication by 2. 2 shift is multiplication by 4. 3 shift is multiplication by 8. So 2, 4 and 8. So R1 into 8 plus R2 is added to R3. R1 into 8. Why? Because R1 need to be left shifted by 3. When you do 3 left shifts, it is multiplication by 8. So R1 is multiplied by 8 added with R2, and the result is stored in R3. This is logical shift left, where need not to preserve the sign and all, something like this. Okay, that's why it is given logical shift left by 0 to 31 places. Okay, logical shift left till the 0 to 31 places, fill the vacated bits at least the significant end the word with zeros. Okay, logical shift right 0 to 32 places, fill the vacated bits at the most significant end of the word with zeros. So you see, whenever there is a logical, here the remaining bits, vacated bits are filled with zeros. But if you look at the arithmetic shift is the synonym for the logical shift left. You can see arithmetic shift right means, this is very interesting. This is what we have seen right now. Arithmetic shift right by 0 to 32 places, fill the vacated bits at the most significant end of the word with zeros if source operand was positive, or with ones if source operand was negative. That's all very simple. So arithmetic shift left or arithmetic shift right will preserve the sign bit. That's the only thing you need to remember, which has been discussed already very clearly. So rotate right, ROR means rotate right. You can shift up to 32 shifts, but in 8051 you need 32 instructions. But here on the go, you can do the right shift. Okay. So rotate right with extended by one place. Okay. So which means extended means will carry. Carry will also be included in this case. So logical shift left, logical shift right, arithmetic shift left, arithmetic shift right, and rotate with extension. So here you can see logical shift left with the content of R2. R2 will have some value. So that many shifts you have to do with respect to R3. Then it is added with R5 and the result is stored in R4. Okay. This is something like 4 address instruction. Okay. So how many shifts can be represented in the register also? Instead of immediate value, how many shifts you have to do that can be stored in the register itself, which is very much comfortable in most of the applications, right? So this is one context with respect to the shifting, right? Okay. So setting the conditional codes. Conditional codes means what? They are saying the flags as conditional codes. In an ARM instruction, they are saying flags as a conditional codes. Okay, that's all. So shifting, that is what we have discussed right now. Here you can see logical shift left 5 locations means you are shifting 5 locations, appending zeros in the vacated places, right? Logical shift right 5 locations means filling zeros in the vacated places, right? Filling zeros in the vacated places as you see here. But here you can see arithmetic shift right, positive operand, right? Because the MSB is 0. Here you can see the most significant bit is 0. Hence, the MSB is preserved by doing the right shift, arithmetic shift right. If MSB is 1, that 1 is being preserved. So positive number is preserved as positive number, negative number is preserved as negative number while performing the arithmetic shift right. Similarly, arithmetic shift left. And rotate right, and rotate right means what? LSB will become MSB. And extension means what? Carry will also include it. So LSB will become the carry part and carry content will become the most significant bit. It goes on. And this is another instruction which says conditional code instruction, where you can see add S R2, R2, R0 and add with carry R3, R3, R1. So 232-bit numbers are added, adding an S to the opcode, right? Adding an S to the opcode standing for set conditional codes. So set the corresponding conditional codes while performing this operation, which we can use it for the next thing, right? So 32-bit, while adding the 32-bit numbers, I want to do the 64-bit addition, where as like how we do multi-byte addition in 8051, even though 8051 is an 8-bit register, we can perform 16-bit addition by adding the lower significant byte and storing the lower significant result, and adding the more significant byte and storing the result, and having that as a 16-bit value. Similarly, with 32-bit processor, we can go for 64-bit addition. So lower order 32-bit in R0 and R2, which is added, and store the lower order 32-bit value in the R2, lower order 32-bit in the R2. And by the time if there is any flag sets means, by pressing S, by adding this S symbol, that will set the carry flag, say for example. While adding this, the carry flag sets means, again adding with MSB, adding along with carry will help us to give the right 64-bit answer while performing the addition. And there is a multiplication part available. Okay, there are multiplication instructions separately as like MLAB. Here, mul R4, R3, R2 means content of R3 and R2 is multiplied and the product is available in R4, right? And there is something like multiply and accumulate. Multiply the content of R3 and R2, add the content with R1 and store the result in R4. So this multiply and accumulate is mainly used for convolution, where convolution is DSP, DSP is convolution, which we'll be discussing in the next semester beginning. That's why I'm eagerly waiting for doing this, right, MLA. So we can, that's why these are all some DSP related instructions, where multiply and accumulate is the direct instruction to perform convolution. We'll be discussing about that soon. Okay. So reverse subtraction. Okay, reverse subtraction kind of things with logical shift left, #2 logical shift left with the logical shift instruction. When we talk about data transfer instructions, whenever there is a data transfer between the memory to the peripheral means always load, store, load, store, load, store, load, store. Okay. So load store is the only thing. We do not worry about much about it. Quickly we'll touch upon it, right? Because already we have discussed everything. Yeah, but much more interesting things are there, which I'll brief about it now. Okay. So when you talk about data transfer instruction, single register load store instruction. It starts with single register load store instruction. As you see here, single register load store instructions. It's very simple, right? Here you can see load LDR, load register. Which register need to be loaded? R0 need to be loaded. From where? From the memory, pointed by R1. So this bracket, the square bracket is a pointer. So R1 is pointing some data memory location. Go to the memory location pointed by R1 and bring that 32-bit content to the register R0. Exactly speaking, load the register R0 with the content of the memory location pointed by R1. Here you can see load the register R0 with the content of the memory location, 32-bit memory location pointed by R1. Similarly, store means what? Store the content of the register R0 to the memory location pointed by R1. There at symbol means it is indirect addressing. Here within bracket means it is indirect addressing. So this is another way of indirect addressing, right? So there is nothing like direct addressing, because direct addressing is not necessary here, because directly you cannot able to address the memory. Making the R1 to point the table 1, making the R2 to point to table 2, and copying the data from the table 1 and pasting the data to the table 2. Okay. So table 1 is the source of data shown here. Table 2 is the destination of data source. So always LDR and STR. Okay, with respect to data transfer instructions, simply write LDR and STR. That itself is more than enough for us. Okay. And again here, LDR, STR, something like this. And step 1 R1 on onward and step R2 on on. Onward means what? 4 locations you have to increment. Several times we keep on discussing, right? Always we have to increment 4 locations, right? 04 C0, 04 C10, 04 C10, 04 C10. Always it has address should be pointed with 04 and C10. Something like this. It's continuously. So continuously, if you have to copy from the table means from byte by byte we should not increment, because one read means it is 32-bit read, right? So 4 address read. That is why 4 locations need to be incremented before fetching the next location, as we know very well, right? Okay, how to do the 4 location increment just like that means, which is called as LDR R0, R1 hash 4. This hash 4 denotes, so this is pre-indexing. So within the bracket, if you put hash 4 means it will be incremented by 4 and that content will be moved to the register R0. It's very simple. Within the bracket, if some hash is given means it is pre-indexing. If there is an exclamation mark, then you can say it is auto increment, auto indexing, right? Then you can say it is auto increment or auto indexing. So continuously it can increment by 4, obviously, right? Okay. So that is what auto indexing. That we call it as auto indexing, which is very much useful in the higher end applications, right? Okay. Here you can see load the data register R0 with, this is post indexing. This is post indexing. Outside the bracket means post indexing. So loading the content of the memory location pointed by R1 to R0, then increment R1 by 4. After copying the content of R1 to R0, then R1 location is incremented by 4. This is post indexing. Within bracket, if you give hash 4 means it is pre-indexing. Within bracket, if it is 4 means it is pre-indexing. Okay. So if you go through this, then it's very interesting. If there is an exclamation mark, then you can say it is auto indexing. It keep on incrementing automatically. Okay. So when you write a loop, exclamation mark will help us to do the automatic increment like this. Okay. So that is very clearly given, right? So B means LDR, B means byte. Only if you are interested in copying the byte alone means byte, which was already discussed, right? This is very interesting, right? Load multiple registers and increment after. LDMIA means load multiple registers and increment it after. Load multiple registers and increment it after. That is what we have given, right? So how to load the multiple registers? what are the registers means that register should be given into the parenthesis like this. Okay. So what are the registers to be loaded? R0, R2 and R5 are the three registers which has to be loaded with the content of what? R1. You can see R0 is loaded with the content of the memory location pointed by R1. Then R2 is loaded with R1 plus 4. R5 is loaded with R1 plus 8. So the three consecutive locations pointed by R1 is copied and pasted in R0, R2 and R5. So stack means what? Pushing the stack and popping the stack. So while pushing, it has to increment. While popping, it has to decrement. Okay. So increment means ascending. Decrement means descending. So ascending and descending related to stack related instruction means empty ascending, full descending, empty descending, and full ascending. There is something like ascending, descending, empty ascending, empty descending, like the things. Okay. So here you can understand this clear. Load multiple registers with increment after and auto increment. Exclamation mention auto increment. R0 is the pointer, right? R0 is the pointer. So R2 to R9 registers need to be loaded with the content of the memory location starting from R0. So R0 content is copied. R0 is pointing one memory location. It go to the corresponding memory location, copy that value, put it into R2. Then increment by 4, copy it, put it in R3. Then increment by 4, copy it, put it in R4. Similarly, 8 registers are loaded with 8 32-bit locations because of the presence of exclamation mark. Okay. Then copying those register content and pasting it into the corresponding locations pointed by R1. The store the multiple registers with increment after. So R1 is pointing some memory location. Copy the R2 content to the memory location pointed by R1. Then R1 is incremented by 4. Then R3 content will be stored to the memory location pointed by R1 plus 4. Then R4 content is stored into the memory location R1 plus 8. Like that it goes on. So just like that, within this two instructions, 8 register contents can be stored into the memory, or 8 register content from the memory to be loaded into the registers, just like that. Okay, these are all 32-bit contents, right? If you want to push it into the stack means STM, store the multiple registers with full descending. So load the multiple registers with full descending. Load the multiple registers with increment after. Store the multiple registers with increment after. Those things, all the 8 registers is given clearly. This you can very well understand if you go through this. Okay. So those stack related things was very given clearly, right? Okay. Stack related things was very given clearly. Okay. So here you can see the register R9. Here you can see store the multiple registers with increment after means R9. R9 is acting as a pointer, right? R9 is having some location. It has to go to the content of R0. Content of R0 should go to the memory location pointed by R9. And R9 is incremented by 4. And the content of R1 is stored into that location. Then it is incremented by 4. Then content of R5 is stored in that particular location. Okay. So increment after. That's why it is after incrementing. So increment before, there is something like store the multiple registers. Increment before means R9 is incremented by 4 before itself. R9 itself is pointing here. Incrementing by 4, then R0, R1, R2. So here increment after means from the pointed location. Increment before means before itself it will increment, then it will paste it. Very clearly given. Similarly, store the multiple registers with the decrement after R9. So decrement after. Okay, so store the multiple registers with the decrement after. So R0 content is decremented after, and then storing the register content R0 to the corresponding memory location pointed by R9. So R0, R1, R5 is stored here like this, and decrement before itself it is getting decremented, and R0, R1, R5 contents are being stored. So multiple register data transfer addressing modes are clearly given. So in summary, table 3.1 very clearly given about increment before or increment after, decrement before or decrement after, whether it is full ascending or full empty or full descending or full empty. Control flow means Very simple. All of you are very much clear about it. Jump carry, jump no carry, jump 0, jump not 0, decrement and jump not 0. Here like so many complications of the branch. Here we call it as branch. Always we need branch. Only instruction is branch. What are the conditions? Branch if equal, branch if not equal, branch if plus, branch if minus, branch if carry clear, branch if low, branch if overflow, branch if greater than, branch if less than, branch if higher, lower, same, etc. So many conditions are there where we can use it as per our convenience. These are all the branch condition instructions. So branch link instruction means there is something like link instruction, which is nothing but the R14 is a stack pointer instruction, as we know very well. So while branching, the return address can be linked to the stack register. So it is not necessary to push, right? So branch with link means the return address can be linked to the register automatically. This is quite interesting, right? So branch with link instruction means return address will be stored to the stack automatically while the instruction itself. That's very interesting. So branch with different conditions and branch with link instructions. And there is something like supervisory call, which is nothing but subroutine. It is something like software interrupt. Supervisory calls are nothing but a software interrupts. Very simple, right? You can see software interrupts are called as supervisor calls. Okay. SWI stands for software interrupt, but it is pronounced as supervisor call. Supervisor call means it is software interrupt, which is used for displaying the text and all. We'll be discussing about that soon. So this completes our third unit, which gives a brief overview about the instruction set of ARM processor, where data processing, data transfer, and control flow instructions.